You're listening to MedX, the Medical Extrusion Podcast. Presented by U.S. Extruders. Extrude with confidence. Custom extrusion equipment designed for you and your application.
Welcome to the MedX Podcast. I'm your host, Steve Maxson. Today's guest is Tyler Ware, president and owner of GenX Medical based in Chattanooga, Tennessee. GenX Medical is an ISO 13485 certified producer of medical tubing from microbore, large bore, multi-lumen, and more. Tyler, thanks so much for taking the time out to join the MedX Podcast today.
Hey, you're welcome, Steve. Thanks for having me. It's real good to see you, buddy.
Let's start off to talk about your background, how you got into medical extrusion in the first place.
Okay. Well, I graduated from UTC with a chemical engineering degree. My first job out of college was actually doing extrusion. And then I didn't really like it so much, got into working on houses and building houses. And then on this fishing website, one day somebody put a post up there, what do you do for work? And I said, I used to do extrusion. Lo and behold, a friend of mine, his name's Michael Holt, was looking at that website, saw that I did extrusion, was looking for an extrusion guy. So he sends me an email and says, hey, you want to get back into extrusion? So I'm like, yeah, sure. Why not? It was the housing market was not good. It was 2009. So then me and Michael went out and fished for a day, saw if we could get along. And he decided to hire me. And so I started my medical extrusion at a place called Excellent in Trenton, Georgia, and had a lot of experience, walk out the door and was kind of thrown to the wolves and learned a lot there. And then from there, you know the story from where you hired me to help you out, and you kind of threw me to the wolves a little bit. So then that forced me to learn a little bit more. And so that's just the story of, just kind of falling into place. And I didn't seek it out. I just knew about melted plastic and was in the right place at the right time. So we like to just help other people out and try to give them the opportunity to. It's a hard industry to get to, and a fun one. Changes so much. And every day's new. But yeah, I was just at the right place at the right time.
Yeah, your passion for fishing and medical extrusion came together to really help you out.
Yes, they did. Yep. So 8 hours on a boat was probably the best interview I've ever had in my entire life. And then I think we went and had lunch, and then another lake. And Michael says, well, if I can spend 8 hours on a boat with you, then I think I like you. And so, because you're close, you're tight. And that was the first day I ever met him. And still friends with the guy. So it's awesome. It's a small community there.
Yeah. You're going on 7 years in business now, right?
Yeah, 7 years.
In med tech, it typically takes 3 to 7 years for a program to go from prototype, V&V to serial production. So Are you starting to see some of the programs that you worked on at a very early stage go into higher volume production?
For sure. Yeah. One of our very first early on customers, we started out, we're making 200 tubes. And we're like, and the next thing you know, they're like, oh, we need 5,000. And we're like, 5,000. And so then you put out 5,000, you learn what issues you had going from 200 to 5,000. And so I think that one we're making 50,000 a month now. And this happened. We probably have 4 customers that have production going right now.
Okay.
I would say 35% of our extrusion time is making production items. And then we've had some that are right at production, and then the companies just fall off the planet. You don't hear from them anymore. They're no longer existent. So you think they were about to go, and it was ramping up, and then it just goes away. But yeah, so I would say 3 years is what we've seen, really.
Okay.
I know we've also come in as secondary suppliers on some of these and ramped up much faster because we're taking business from other companies. But the ones that start from nothing, it's been about 3 years. You start off with 100 tubes here, and then you're putting out 5,000, 10,000 a month. And then you get blanket orders for a year out. And so they try to forecast, and we try to just keep supply going so nobody loses. And yeah, it definitely takes a while. And so you got to learn to manage as you're just pumping stuff out. And like when you don't really know if orders are going to come in because they're not production orders. And so it's kind of hard to grow a business from scratch, not knowing that, not having
Yeah,
that production. But it's going good now. Yeah, we're having a great
that's good.
time.
Yeah, those forecasts give you some visibility for the future so you can plan infrastructure, resources.
For sure. And it's important for them so that we can be ready so that then we don't fall behind, because
Right,
when they need the tubes, we need to have them ready to go. And so, yeah, the,
right.
the forecast is a win-win. So it helps us plan, helps us be ready so we don't fall behind and get lead times too long and all that. So,
Okay. Let's talk about your partnership with Chamfer, the online marketplace for
yep.
catheter components. You were one of the early sellers for Chamfer, 5 years ago. How has that relationship transitioned? Same kind of question as before. Did some of the programs or prototype tubing that you sold through Chamfer early on transition into production, or just give us the lay of the
Yeah.
land of your relationship with Chamfer and how that's affected your business?
Yeah. So, I mean, I think we were actually the first person to tell Chamfer, we're going to pull the trigger, let's go. And so then there was a group of us that all put our products on there at the same time. Yeah, but we have a customer that had 4 or 5 production items. They came to us through Chamfer and made a HDPE, LDPE tube for another customer, and then they're like, "Oh, we needed a needle too," and I didn't have a way to anneal it,
Hmm.
so they're like, "Oh, we don't want it." And so we just put it on Chamfer, and customer bought it. Didn't hear from them, and then probably a year later, they're like, "We love these. We've been doing development with these," and so then they started ordering that tube. Then that led to a relationship, and we started producing other stuff for them. And yeah, that actually, we have a pretty good relationship with them, and they're one of our top 5 customers now, which is pretty cool. And then all the time we go back and we contact customers from Chamfer and say, "Hey, we see you bought this. Is there anything else we can help you with?" And then people are like, "Oh, you do online? I mean, you can do custom stuff too." And so then we do that, and it's definitely given us more customer base. I think we have like 75 customers. I would say
Hmm.
probably 15 or 20 have come from relationships on Chamfer, with the one being actually a very large relationship now and a lot of production. So that's cool.
That's a
Yeah,
great
it's
story.
helped us out for that. I know it helps our customers out a lot because they're like, "Oh, we've been buying this and buying this. Can we now get more specific?" And then they dial it in close. And so I think it's a win-win for everybody.
Great. Tyler, from our experience working together, you're a real hands-on guy and you push yourself to solve very challenging extrusion applications.
Yes.
I believe I might have, as you mentioned, I might have presented some of those challenges to you, right?
You definitely presented challenges to me. That's a whole podcast on its own, Steve.
Exactly. Talk about some of the things that you've done to bring capabilities in-house so that you're less reliant on others and it allows you to do some things technically that others can't do.
Right. So we do a good bit of that actually, and that kind of just came out of need. So I would say that one of the first things we did is we ended up making a coiling machine just because we had a customer that wanted some coil duct, and we're trying to get it coiled. And then people are like, "Oh, you really need this," and we're like, "Yeah, we really need that." And then they started no quoting, and I'm like, "Well, let's turn this puller we have into a coiler." And so we had a puller, and so we weren't using it. Built the whole thing to coil over that. Well, actually, before that, we had tried to purchase some peak from a customer, a supplier, and they really wanted a lot of money, and they wanted me to pay up front, and we're new, and we didn't
Mm.
have a lot of cash. And I'm like, "Can you work with me on terms?" And they're like, "No, pay up front cash." So we canceled our PO. Somebody sent us a 10-pound sample of peak. We made it ourselves. So I'm not going to mention the name, but thank you very much for ripping me off, because then I was able to
Yeah.
start making peak myself. Then through running peak and coiling peak on this machine we had, we started learning that we need to make the peak stronger. So then we made another machine to draw it down.
Hmm.
So we make a filament, and then we have 2 rollers and a heater, and this one runs at this speed, and we can set the speed of this one and stretch it basically to orient it all. And we made that. We make all of our taps. We make our own watts just because they can do they do what we need and not too much. And then I'd say one of the biggest things we've gotten is a CNC. So we make all of our own tooling in house now. So that's really helped the process of making multi-lumens. We went through 12 dies 2 weeks ago to make a multi-lumen for a customer, and that was over 2 days. And I mean, if you had to send that out and you're like, tweak this, I need a couple thou here and a couple thou there, and it just adds up. But we wanted to get it perfect, and we got it perfect. And so that helps a lot. We've been making inserts for our co-extrusion heads to do stripes, so then we can change the stripe width and really help dial that in. We just made a multi-lumen with a stripe. Never done it. Somebody said, "Can you do it?" And I'm like, "We'll try." And we just made all this stuff, and it worked out. So yeah, I mean, it really just comes from a need. And like when people are asking for stuff, and then I see what have you gotten before, and they send me a picture of what they bought, and I'm like, yeah, we can definitely beat that. And so then we figure out how we're going to do it and make it. And sometimes you fail, sometimes you learn. I mean, we're running the CNC for a long time, and I'm talking to my buddy. He's like, "Dude, you're doing it wrong. No wonder you're killing tooling." And I'm like, "Oh, yes, we're doing it wrong." And so like we learned, but we were making tooling. We were just going about machining it the wrong way. I knew how to get it to do what I taught myself to get the CNC to work, but I didn't know how to optimize my tooling. And so, yeah, it's just a lot of stuff. So it's fun.
Yeah.
We make our own payoffs as well for several products that are very specific, and it's one payoff for a specific item because nothing else will do what we need to do. So
Excellent.
yeah, it's cool.
That's very interesting. Let's transition to some of the interesting extrusions that you've been involved with, and we'll start with the kink resistant peak coil reinforced tubing that you referred to earlier. So you mentioned that not only do you extrude peak filament, but you draw it down to align the polymer chains, increase the tensile strength. I know there's a core mandrel that's usually used for a manufacturing aid in that process. Walk us through that kink resistant peak coil reinforced tubing technology that you've developed.
Okay. Yeah. So we do two types of coiling. We coil a metal, and then we also do a peak. And so the metal one we put over an HDPE core that we make. And so a lot of people use a acetyl core. It's hard. It's pretty easy to make round. It doesn't stretch very well. So we made ours out of polyethylene so that it's really slick, stretches, and comes out. And so we extrude the polyethylene core, and then we extrude over that with whatever resin is needed. And then we'll go and coil over that. And then we'll run that back through the extruder. And on this particular process, we do a vacuum. So we're vacuuming it down onto the coil, and it kind of makes a rigid surface, but for the kink resistance is actually what this customer wanted. And so then after we put the second layer on, we'll pull the core out, cut it to length. And so that's a product. Another one we make is we'll get Teflon on top of silver plated copper. And this Teflon stays on the wire, and then we'll extrude over that, coil over that with peak, extrude over that, and then we run that second extrusion that was called a pressure extrusion. So it's seeing really high pressure inside the die, and it fills in all the gaps of the coil, and it leaves you with a really smooth OD. For that process, you have to we haven't been able to use our core that we make yet because it's so high pressure, high temperature, a lot of force, and it just breaks the plastic core. So on that one, you need a metal. And so that's why we use silver plated copper. So there's kind of a difference. We're still working on it. We haven't given up. We're still working on trying to make our own core that will go through pressure extrusion and hold up. And just because we like to be self-sufficient, and nobody wants to wait 6 weeks on somebody to get core to us. And then sometimes it's trash, and you're like, okay, another 6 weeks in. And then you're having to argue whether you think their core is bad and whatnot. And so, yeah, it's a cool process, and they both end up very different look and different feel, but they both have the same thing as kink resistance, and that's what people are looking for with the coiling. So
you mentioned that you're using a pressure tooling setup so that you could get the outer jacket kind of within the interstices of the coil members. An alternative approach would be like tubing tooling where you kind of lay it on after the die. Can you just briefly explain that, the difference between pressure tubing tooling and tubing tooling setups for
Yeah.
folks
Yeah.
out there
So
that are, go ahead.
yeah, I mean, and so with the tubing, like we're basically, the polymer's coming out of a die that might be 200 thousandths OD, and we're drawing it down onto a core that's say 100 thousandths OD. And so then you hook a vacuum up to the back to suck the air out and pull it down onto it. And so
Mhm.
this method, you could basically make a tube, you get the walls right, you get the concentricity right, and then you feed through and suck it down onto it. And so that if you have ridges such as coil or braid, basically it's just going on top of it.
Mhm.
Pressure extrusion, you have to have a tip that is just a few thousandths over the size of your max OD of your core, so that you feed it through, and then you have a die that is the size of the product you want. And so this polymer is hitting all of that coil product, or we coat too, and is pushing the polymer to all of that long before it comes out the die. And
Mhm.
so it'll see 2000 psi, and then basically the die acts like a squeegee and just like pulls all the extra material off. And so all that material just gets hung back there and is pushed into the braid, and then the die just makes it smooth with a nice OD the size you want. And so one of them, I mean, when it sees 2000 psi inside that head and you're pulling on it, it's pulling some force. And
Mhm.
I've seen it want to pull a puller across the room where it's pulling it backwards where somebody didn't have the belts tightened down. So yeah, that's why we just can't do it with the polymer core. We got to use a metal core. But
Okay.
it's really just it's easier to draw. To say, okay, here's where the tip. Our tip doesn't stick out of the die on a pressure extrusion. It sits back in there,
Yep.
and
Yep.
so you have this gum space of like a quarter inch of polymer before it comes out the die, and so it's just forcing it in everywhere.
Okay.
But it
Interesting.
makes a huge difference. It really makes it smooth.
Yeah.
And it
Let's
allows that material to adhere to the polymer on the inside as well too.
Right. Gotcha. Better bonding or of the two polymers, inner
For
and outer.
sure. Yeah.
Let's talk about some of the work that you've done to overcome some of the challenges associated with extruding large bore, very soft tubing. So when I say large bore, 24 French, 300 thou, that's getting up there for minimally invasive tubing. For normal semi-compliant materials, nylon 12, higher diameter P-backs, maybe not so much of a challenge. But when you're talking about very soft, short A polyurethanes, that can be very challenging. Walk us through some
Yes.
of the challenges associated with extruding large bore, very soft tubing, thin wall.
Right. So a lot of large tooling is made with calibrators. So some type of sizing disc
Mhm.
and some vacuum. So that's we do this on several tubes that are large. It's just a common thing. But then you get the sticky tubing, 25D P baxes all the way to say 55 P baxes, 80As, 90A urethanes. Um, I mean, we run some of these up to half inch
Mhm.
and 5 thou wall, and it's just so sticky. You can't do a vacuum sizing, or it's just going to stick and adhere to everything. And so we have to go back to a conventional iris method. And so then you're working on like how do you actually keep this thing in size, because if tube floats all the way, the top's going to stretch a little bit more than the bottom because the top's sitting out of water and takes
Mhm.
longer to cool. So then that's going to throw your concentricity off, your realignment if it reflows, all of that stuff. So you have to have tricks on trying to hold it under the water till it's already set, and then basically it can't touch anything after that. And so try to get water off of it without it touching anything to blow the water off. The guides going into the puller have to be exact. They need to, or it's just going to be hanging up on that. And so then also when you're doing this type of method, you can't really vacuum. And so then you're having to pump ID air inside of it, and you get sticky thin wall tubing and you're pumping ID air in. And if you try to cut it, or if you try to pinch it off, that little bit of pinch sends the air wave back. And so we've made a couple devices here that allow us to take this material up, keeps it straight, keeps it from kinking so that it just holds the OD very consistent. And then we allow it to cure. We can cut it off and then we'll ship it to people. So just taking it up and cutting it to length is it's such a hard thing to do. It's just not. I don't know. We have one or two people that can handle this stuff just because of the
Mhm.
stress of it, and yeah, I mean it's going through the laser mic at 10 thou smaller than it actually is, and then
Yeah.
it might grow another 10 thou after that, and so you're trying to hold 6 thou, but you're running at 20 thou below where you're going to be hitting. And so we just have tricks on how to handle that and get everybody to where when we spend all day making this, it's going to actually pass specs
Yeah.
tomorrow.
Yeah. What's
So
the lowest durometer or softest material that you've worked with?
we tried to work with 25A, which is crazy because you think 80A is soft. We run 40A a lot. So
Yeah.
it's kind of like a TPE. So it's 40A of this material can be a lot easier than say like a 74 Tico Flex, just
Uh,
because the TPE is not as tacky, but it is very stretchy. And we've made it into really small products before, and it's tough.
okay.
Yeah, but I mean that we run a bunch of 60, and so those are more well. So it's just a different family. And so when you think about like a soft urethane, it's very different than a soft TPE. So
Okay. Gotcha. I understand that you developed some extrusion technology to embed metallic or monofilament structural members longitudinally within the wall of tubing
yes,
to increase tensile strength, reduce elongation, or it could be, a signal wire or fiber optic
yes.
wire. How do you approach an application like that? Do you work with the customer to define the type of structural member and the positioning within the wall to kind of maximize the balance between flexibility and bending? Or is the customer just sending you a print saying, "Can you make this?" Is it an iterative process?
We've done both.
Okay.
Yes. So we've done both with customers to where, they thought they wanted metal in the wall and they didn't want metal. And then we tried PEEK in the wall. And I've also done a metal inside a multi-lumen wall. That was just the customer's design. And then one of them, we have one that's in production that we put some filaments in the wall. And that one was actually a drawing already. And I think the customer was having trouble getting it consistent. And
Mhm.
so we went through a lot of iterations on tooling to make that product. And so, yeah. And so one of the things is like we draw down tooling. I mean, your polymer draws down to make a tube, but if you're putting a filament in the wall, a filament does draw.
Hmm.
And so you basically have to use a 1-to-1 drawdown ratio. And it makes it really tricky. And it's not something those people are used to doing. So that was something that we had to learn the hard way. We're like, this is not working.
Yeah.
And what's going on? And I'm going, oh, we're trying to draw this into the wall, and this stuff doesn't draw. And
Right.
so then it's leaving scars and little tear marks. And so we learn.
Okay. Is it typically a single structural
I've done
member or is it multiple?
both.
Okay.
So typically you would want two. And so what this is used for is it's really flexible tube, but then because you got members in the wall, it has a huge tensile strength as well. And so it's like a piece of spaghetti that can lift a 10-pound weight. And you're going, what? And that's what it feels like. And so it's
Gotcha.
just limp like a noodle, but then has so much tensile strength from what's in the wall. And that's what it's used for, is that they need it to have that force. So
So you talked about earlier about building some of your own equipment, payoff. So I imagine you built the payoff to deliver that structural member within the wall, the tubing as well, right?
yes, yeah, we've been through about 4 or 5 iterations of payoffs actually, just because you try to. I mean, we're making it, and we're like, oh, we get a complaint about, hey, this looks like it's like popping to where maybe the payoffs got too much tension or bouncing,
Hmm.
um, and so yeah, we've been through a lot, and we have a really good one now. So cleans everything, pays it off, and it's a really short distance. So if you're using a polymer filament and it's wanting to bounce a lot, it will want to stretch. And so
Hmm.
you want to get that distance as close as possible, because obviously a 10-foot piece is going to stretch more than a 1-foot piece. And so if you can limit the distance from a payoff to the back of your extrusion head with fibers, then you limit the amount of bounce and stretch, and you get a lot more stability. So
Gotcha. Tyler, this has been a great discussion. It went by so quick. It's so fascinating always to talk to you. I've mentioned before we started, we've sat at bars and hung out and just talked about extrusion. And now we got to do it on a podcast together. So I'm
yeah,
really fortunate to have this conversation with you today.
yeah, it's been good. I like to share knowledge with people, and we have a couple of things that are secret that we don't share, but I like to educate people, and just at least there's enough tubing out there that I'm not worried about somebody trying to take what I do. We're comfortable with what we're doing. We make good product, and so it's cool just to be able to go out and talk about extrusions and let other people maybe get some ideas and help them out. So yeah,
Excellent.
somebody might be listening and they might be like, I want to get into that. And you know what? Go for it, because it's
Yeah.
a fun industry. So
Yep.
I encourage people. I'm like, do it. It's very
Yeah.
cool. So
It is a great industry. And hey, thanks again, Tyler. It's been great.
Steve, thank you very much. I appreciate talking to you, buddy.
All right, see you, buddy.
All right.
Thank you for listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. All links are available in the show notes.